Hello everyone, welcome to Narayana online digital classes. In today's class, we are going to discuss some problems based on point of concurrency and a family of lines. Okay, let's get started. Question number 1. See here, the line x plus lambda y minus 4 equals to 0 passes through the point of intersection of 4x minus y plus 1 equals to 0 and x plus y plus 1 equals to 0. Then value of lambda. So obviously, here this line is passing through the point of intersection of these two, means obviously lines are concurrent. So these two are the given lines. These two are the given lines. So this line is passing through the point of intersection. See, this line is passing through the point of intersection, means given lines are concurrent. Okay na? Given lines are concurrent, means if 3 or more than 3 lines passes through the same point, then lines are said to be concurrent. If the lines are concurrent, then what is the condition? Determinant of a1 b1 c1, a2 b2 c2, a3 b3 c3 equals to 0. So that value must be 0. So here a1 value 1, a2 b1 value lambda, c1 value minus 4. So from the second row, from the second equation, 4 minus 1 1. From the third row, 1 1 1 equals to 0. Now if you simplify this one, means expanding determinant. So first 1 into eliminate the row and exclude this row and this column, data of this 2 by 2. Then minus lambda into data of remaining 2 by 2 plus minus 4 into data of remaining 2 by 2. Then we get lambda value as a minus 22 by 3. Okay na? Is that clear? Okay. See here how to expand lambda determinant. So 1 into exclude this row and this column. Exclude this row and this column. So if you exclude this row and this column, we left with what? We left with these 4, minus 1, 1, 1, 1. So determinant of 2 by 2, minus 1, 1, 1, 1. Then next for the second one, minus symbol, minus lambda into determinant of remaining 4. So data of 4, 1, 1, 1. Then plus into minus 4 into determinant of 4 minus 1, 1, 1 equals to 0. So if you expand this one, first multiply these two. So 1 into minus 1, upward symbol minus, AD minus BC. So minus 1, then minus lambda into, so it is a 4 minus 1, then minus 4 into 4 minus half minus plus 1 equals to 0. So if you simplify, there you get minus 2, this will be minus 3 lambda, this will be minus 20 equals to 0. So from this one, lambda value equals to minus 22 upon 3. Okay. Then question number 2. See, if O is any point inside the triangle, ABC, the lines OA, OB, OC meets BC, CA, AB respectively at DEF such that ratio is given. So BD is to DC equals to 3 is to 5 and C is to EA equals to 4 is to 7. Then we have to find AF is to FB. Okay. So here we use one theorem called Seva's theorem. Okay na? So we have a Seva's theorem. We have a Seva's theorem. So if ABC is a triangle, and O is here what is given? O is any point inside the triangle. Somewhere you may take O here. O is a point inside the triangle. Then the lines OA produce this one. Then another one OB, another one OC. So these three are intersecting the sides BC at D, then AC or CA at E, and another one, this will be AB at F. Then, so we have the relation, so BD upon DC, so BD upon DC into then CE upon EA into AF upon FB. So into AF upon FB is equals to 1. So this is Seva's theorem. Okay. So remember the statement. You can derive this one in a very simple manner. Here find the equation of OA. Let A coordinates are some x1, y1. A coordinates are x1, y1. Here O, without loss of generality, let O as a 0, 0. Okay na? Take O as a 0, 0. We can find the equation of OA. Then, so here OA is dividing this line segment in minus L11 by L22. So find the ratio. Similarly, find this ratio. If you multiply, result will be 1. Now proof is not required. You just take the statement. So this value equals to 1. Now come to our question. So here, what is given? So what is given? BD upon DC. So this value is given as a 3 by 7, 3 by 5. Yes or not? BD by DC is given as a 3 by 5. Then CE by EA. CE by EA is given as a 4 by 7. Then AF upon FB. AF upon FB is a required value. AF upon FB equals to 1. That implies, so AF upon FB equals to how much? So 35:12. So take just other side. So 12 by 35, that equals to 35 by 12. So this is from Seva's theorem. Okay. Remember this statement so that you can do the problem easily. Right. Then next one. See, the number of integral values of m for which x coordinate of point of intersection of the lines 3x plus 4y equals to 9 and y equals to mx plus 1 is also an integer. Means here two lines are given. Obviously they are intersecting with each other. Okay na? So first given lines. So given lines implies, first one is what? So 3x plus 4y equals to 9, and second one is what? Y equals to mx plus 1. What is given? X coordinate of point of intersection, means they are intersecting with each other. First one L1, second one L2. So here let us find the x coordinate because we require x coordinate. Okay, so solving these two, solving the given lines. So solving the lines, we get, means x coordinate is required. Eliminate y, substitute y value here. Then what we get? So 3x into plus 4y. In the place of y, I can write mx plus 1. In the place of y, I can write mx plus 1. mx plus 1 equals to 9. Right? So from this one, what we have? So 3x plus 4mx plus 4 equals to 9. So here x common. Then 3 plus 4m whole into x equals to 5. So from this one, x coordinate is how much? 5 upon 3 plus 4m. 5 upon 3 plus 4m. Now see here, what is the given condition? X must be integer, also m must be integer. That is a given condition. The number of integral values, so m must be integer. X coordinate, so is also integer, means x and m must be integer. So here let us evaluate m value according to these two conditions, these two conditions. Okay. So here what we have x is equal to x equals to 5 upon, so 3 plus 4m, 5 upon 3 plus 4m. Now think when x will be an integer. Think, so here x is an integer. If the value of denominator may be 1, 5 upon 1 equals to 5. Or if it is a minus 1, 5 upon minus 1, minus 5 means x is an integer. X is an integer. If, so 3 plus 4m equal to what? Either plus minus 1, one possibility. Another possibility, if 3 plus 4m equals to 5, 5 upon 5 we get 1. So third possibility. Another possibility, 3 plus 4m equal to minus 1 means another possibility is 3 plus 4m equal to plus minus 5. Plus minus 5 means here for x we got 4 possibilities. So from this one let us find the m value. If you take plus 1, so 3 plus 4m, 3 plus 4m equals to 1. So from this one 4m equals to 2. So m value, so half, it's not an integer, not the required value. So next if you take m is 3 plus 4m equal to minus 1, second possibility. So from this one 4m equal to minus 4, m value minus 1. So this is one case, m value minus 1, integer. Now come to this one. So 3 plus 4m, 3 plus 4m equals to 5. So 4m equals to 2. Again m equals to half. Again not the required value. So then another case. So 3 plus 4m equal to minus 5. So 4m equal to minus 8. M value minus 2. Means here we got 2 integral values for m. So therefore the number of integral values is how many? 2. So answer is 2. One is a minus 1, another one is a minus 2. Okay. Next one. See, if the line x equals to a plus m and y equals to minus 2 and y equals to mx are concurrent. So here 3 lines are concurrent. Then we have to find the least value of mod of a. We have to find the least value of mod of a. See, just now I said if 3 lines are concurrent, say given lines are, first one x equals to a plus m, say equation 1. Second one y equals to minus 2, equation 2. Then third one y equals to mx, third one. If the lines are concurrent, 1, 2 and this one is 3 lines, obviously point of intersection of 1 and 2, lies on third one. Am I right? So if you solve 1 and 2, we get this point. So this point lies on equation number 3. So I am going to apply this condition because given lines are concurrent. So solving 1 and 2. So we have a point of intersection. Directly here we are getting the point of intersection is what? Point of intersection implies x comma y equals to a plus m comma minus 2. So if you solve equation 1 and equation 2, here I got the point of intersection as a plus m comma minus 2. Since lines are concurrent, okay na, this point has to satisfy the equation number 3. Okay na? So it lies on third one is what? Y is equal to mx. Y is equal to mx. Apply. So here y value minus 2. Minus 2 equals to m into x value a plus m. X value a plus m. Simplify. That implies minus 2 equal to, so am plus m square. Am plus m square. So here we are getting the quadratic. So take minus 2 other side. So if you take minus 2 other side, so what we get? So m square plus am plus 2 equals to 0. Okay na? So this is a quadratic. M square plus am plus 2 equals to 0. Plus 2 equal to 0. Now this is a quadratic in m. So here y is equal to mx. M is the slope of the line. Obviously it contains real value. Okay. So here m is a real. M is a real means therefore discriminant must be greater than or equals to 0. So therefore, so d value must be greater or equal to 0. That implies a b square minus 4ac. B square minus 4ac means a square minus 4 into 1 into 2 greater than or equal to 0. So from this one, so a square minus 8 greater than or equal to 0. So from this one, so a square minus 8. So this will be a square minus 2 root 2 means so if you solve the inequality, what we get? So from this one, so mod of a, so from this one mod of a, so greater than or equal to 2 root 2. Okay. So 2 root 2 into 2 into 1.4 something, obviously it is a 2.8. So therefore mod a is a more than or equals to 2 root 2. So therefore, so what is the least value? Therefore least value equals to, so 2 root 2. Right? See, next one. Here go through the question. A value not equals to b value not equals to c, and so 3 lines are concurrent again. 3 lines are concurrent. So if the lines are concurrent, then just now I said, so determinant of a1 b1 c1, a2 b2 c2, a3 b3 c3 must be equals to 0. Okay, let us apply that condition. So here, so given lines are what? So ax plus by plus c equals to 0. Second one, bx plus cy plus a equals to 0. And third one, so cx plus ay plus b equals to 0. These are the given lines. Ax plus by plus c equals to 0, bx plus cy plus a equal to 0, and cx plus ay plus b equal to 0. So what is given? So lines are concurrent. Okay na? So given lines are concurrent, if the lines are concurrent, then we have the condition that implies a determinant of so a b c, then this will be b c a, then here so c a b equals to 0. So from this one, if you expand, so just now I said first a into, so it is a bc minus a square, then next minus b into, it is a b square minus ac, then plus c into, so ab minus c square, equals to 0. So simplify this one. So this is a abc minus a cube minus b cube minus half minus plus abc, then plus abc minus c cube equals to 0. So from this one, what is the result? abc plus abc plus abc, 3abc take a cube plus b cube plus c cube other side, means we have the relation that implies a cube plus b cube plus c cube equal to 3abc. Means if the lines are concurrent, then so here we got this relation a cube plus b cube plus c cube equals to 3abc. Now let us find the value of this one. Okay, here what is the condition? Here condition is a cube plus b cube plus c cube equals to 3abc. Now using this condition I am going to find the value of this one. So let us go to the next page. See here, this is a required value. Therefore 2 raised to, so it is a 2 to the power a square. So a square, so I can write this one as a b to the power minus 1 by b. This is a 1 by c, means it is nothing but, so it is nothing but so it is a 2 to the power, so required value is what? So it is a 2 to the power, so a square upon bc, right? First one. Second one, so 2 to the power, so b square upon ac. Third one, so 2 to the power c square upon ab. Now bases are equal, powers get added, that equals to 2 to the power, so a square upon bc plus b square upon ac plus c square upon ab. Take the LCM, that equals to 2 to the power, LCM is what? ABC is the LCM. So here a get multiplied, so it becomes a cube. So here b get multiplied, b cube, c get multiplied, c cube. Now we have the condition a cube plus b cube plus c cube equals to 3abc. Therefore in the place of numerator I can write 3abc. So here abc cancel out, abc get cancel out, so we left with what? 2 cube abc, so abc get cancel, so therefore that equals to 2 cube, so that equals to, so required value equals to 8. So therefore value of this one equals to 8. Okay, simple one. Next one, here the line ax plus by plus p equals to 0 makes an angle pi by 4 with x cos alpha plus y sin alpha equals to p. So p is a positive real number. If these lines and the line x sin alpha minus y cos alpha are concurrent, then this one is a good question, beautiful question. Here you look at the question and you observe the given lines. So what you observed? You observe the given lines. So what are the given lines? First one is ax plus by plus p equal to 0 and x cos alpha plus y sin alpha equals to p. Third one is x sin alpha minus y cos alpha equals to 0. Okay na? So now what is given? Angle between these two is given as a pi by 4. Now think about, what about these two? Obviously they are perpendicular to each other, because slope of this one minus a by b minus cos alpha upon sin alpha. So this one is what? Sin alpha upon cos alpha. So m1 into m2 equal to minus 1. They are perpendicular to each other. See here. First take the given lines. So given lines, first one is what? Ax plus by plus p equals to 0, equation 1. Second one is what? So x cos alpha plus y sin alpha equals to p, number 2. Then third one, x sin alpha minus y cos alpha equal to 0. Now, so say equation number 3. Here you observe 2 and 3. So here slope of 2. Slope of 2 says m1. m1 is equal to what? So minus of a by b. So cos alpha upon sin alpha. Then slope of 3. Slope of 3 m2 equal to minus a by b. So it becomes sin alpha upon cos alpha. So here m1 into m2 equal to minus 1. If you multiply, cos get cancel, sin get cancel. Therefore, so line 2 is perpendicular to line 3. Line 3 means see equation 1, say this one, assume equation 2 as this one. They are perpendicular to each other, not equation 1, equation 2, equation 2 and equation 3. Equation 3. Now again back to the question. What is given? Angle between ax plus by plus p and equation 1 means angle between 1 and 2. Angle between 1 and 2. 1 and 2 is how much? Pi by 4 means this one is this one is 1. This one is 1. So angle between this line and this line have an angle how much? Pi by 4. So this one is a 45 degrees. This one is a 45 degrees. Obviously, second angle will be 45. It also 45 because they are perpendicular to each other. So perpendicular to each other. So what it says? It says that ax plus by plus p is a angular bisector. Am I right? See, so it is dividing the angle into two equal parts. So therefore, equation 1 is what? Angular bisector of 2 and 3. So it is an angular bisector of 2 and 3. Okay na? So we have a angle between 1 and 2 is 45 degrees. Therefore so what is what the result we got? So here therefore equation 1 means that implies ax plus by plus p is an angular bisector. Angular bisector of what? Bisector of so 2 and 3. So this one and this one. Okay. Now we can find the angular bisector by using the formula. Okay na? Using the formula. So what is the formula for the angular bisector? So but we have a angular bisector. Angular bisector implies what is the formula? So a1x plus b1y plus c1 upon a1 square plus b1 square equal to plus minus a2x plus b2y plus c2 upon a2 square plus b2 square. This is a formula to find the angular bisector. See, a1 b1 c1, a2 b2 c2. Apply the value. That implies therefore angular bisector implies x cos alpha plus y sin alpha. Then constant is what? Minus p. This one is a1x plus b1y plus c upon a square plus b square. So a1 square means what is a1 square? X coefficient cos square alpha. X coefficient is cos square alpha. Then b square means sin square alpha. Obviously it reduces to 1. So it is a cos square alpha plus sin square alpha. Sin square alpha in the right hand side equal to plus minus of a to x. Second line. So it is a x sin alpha minus y cos alpha, constant is 0 upon root over sin square alpha plus cos square alpha. Okay. Now this becomes 1. We can take plus or minus both the cases. If we take plus symbol, what we get? Therefore angular bisector implies. If we take plus symbol, here we have a x sin alpha. Bring to the left side. So here we are having a x cos alpha. So taking x as common. So cos alpha minus sin alpha. Cos alpha minus sin alpha whole into x. Then y sin alpha, here minus y cos alpha, bring to the left side, it becomes plus. So therefore plus sin alpha plus cos alpha into y minus p equals to 0. Now this is what angular bisector, say equation 4. Equation 4. Now equation 1 is what? Angular bisector. Equation 4 is what? Angular bisector. They represent a same line. Therefore a1 by a2 equals to b1 by b2 equals to c1 by c2. That implies a1 by a2. That implies a1 by a2 equals to how much? So a upon cos alpha minus sin alpha, b1 by b2. So b upon sin alpha plus cos alpha equal to c1 by c2, equal to c1 by c2. What is the c1? P. Here this one is a minus 1. Okay, so from this one a value sin alpha minus cos alpha, b value so minus of sin alpha plus cos alpha. Now what is the required value? So here now verify the options. So if you take a square plus b square, so therefore a square plus b square equals to a square sin alpha minus cos alpha whole square, sin alpha minus cos alpha whole square plus b square, minus becomes plus, so sin alpha plus cos alpha whole square, sin alpha plus cos alpha whole square, a minus b whole square plus a plus b whole square, twice of a square plus b square, that equals to, so twice of sin square alpha plus cos square alpha, that equals to 2. Therefore a square plus b square value equals to 2. Okay. So find the angular bisector, then so comparison, by comparing we get a value as well as a b value. So from this one look at the options, a square b square is required, so a square plus b square value equals to 2. Okay. If you take minus symbol also you get the same result, right. Then next one, here this one is a right answer. Next one, see here again lines are concurrent, then we have to find the point of concurrency. Point of concurrency, see here in the previous question what we got, see here given lines are concurrent, same lines, given lines are concurrent. I think question number this one. So here ax plus by plus c equal to 0, bx plus cy plus a equal to 0 concurrent, then what is the condition? A cube plus b cube plus c cube equal to 3abc. Then from this one we have another result. What is that one? A plus b plus c equals to 0. Okay na? A plus b plus c equals to 0. If a cube plus b cube plus c cube equal to 3abc, then so we have a result. So given lines are what? So given lines implies a ax plus by plus c equals to 0 and bx plus cy plus a equals to 0. Then cx plus ay plus b equals to 0. Here lines are concurrent. Therefore lines are concurrent. Therefore we have the condition. So from the previous case, so we have a plus b plus c equals to 0. A plus b plus c equals to 0. Okay na? Now look at the given lines. So in what case we get a plus b plus c equals to 0? Here x value must be 1, y value must be 1, so that we have the result a plus b plus c equal to 0. a plus b plus c equal to 0. Take the second one. If x value 1, y value 1, then a plus b plus c equal to 0. Here also same. X value 1, y value 1, a plus b plus c equal to 0. Means, so here using this condition, so what is the point of concurrency? So point of concurrency equals to 1 comma 1. 1 comma 1. Okay. Next one. See here, if the lines 3x plus 2y minus 5 equals to 0 and 2x minus 5y plus 3 equals to 0 and 5x plus by plus c equals to 0 are concurrent, then the value of b plus c. Again same. So here lines are concurrent, directly you can apply determinant, det of determinant equals to 0. Otherwise, solve these two, find the point of intersection, and apply in the third line, we get b plus c value. So whichever you feel comfortable, you can do in that one. So here, so given lines are concurrent, therefore I am applying the condition of determinant. So from the first line, so what are the values? 3, 2, minus 5. From the second line, so 2 minus 5, 3. So from the third line, so 5 b c equals to 0. Now expansion. So here, so first 3 into what I said. So determinant of this 2 by 2. Minus 5 3 b c, then second one symbol minus, so minus, so 2 into, so determinant of so 2 3 5 c, then third one minus 5 into determinant of so 2 minus 5 b equals to 0. Now expand. So if you expand, so 3 into, so minus 5c minus 3b, right? Then minus 2 into, so 2c minus 15, then minus 5 into, so 2b minus half minus, so 2b minus half minus, so plus 25 equals to 0. Now common simplification. So here we have a minus 15c, right? Then minus 9b, minus 4c, so minus half minus plus 30, so minus so 10b, okay na? So minus so 125 equals to 0. Now if you simplify here, what we have? Minus 15c minus 4c minus 19c, I am writing here. So here this will be minus 19c, then minus 9b minus 10b, minus 19b again. Now constant, so 30, so minus 125 minus 95 equals to 0. So from this one you can take out 19c plus 19b equal to minus 95. Take 19 other side. What is the required value? B plus c. Take 19 other, b plus c equals to how much? Minus 5. Okay na? So b plus c value equals to minus 5. Again simple one. So here you can do in two ways. This is one method. So another method is so solve these two lines, find the point of intersection, and then substitute in the third one. Again you get the same value, right? Then let us go to the next one. Here 2 is a root of ax square plus bx plus c equals to 0. Then point of concurrency of lines ax plus 2by plus 3c equals to 0. So before going to this question, let us recall the formula, family of lines. See, what is the formula? So consider a line L1, consider another line L2, okay na? Now this is a point of intersection, any line passing through the point of intersection of L1 and L2, any line passing through the point of intersection of L1 and L2, this line is given by what? L1 plus lambda L2 equal to 0. Here lambda is the parameter. How many values are possible? Infinite values are possible. Means you may have another line. So all the lines are given by this equation only. L1 plus lambda L2 equal to 0. So it represents a family of lines. L1 plus lambda L2 equals to 0, where lambda is the parameter. So here L1 is a, L2 are the given lines. So this is the point of concurrency. So how we get? By solving L1 and L2, we can find the point of concurrency. Am I right? Solve these two, we get this point. Okay. Now here I am using this concept here. Now come to the question. What is given? So 2 is a root of ax square plus bx plus c equals to 0. Means first take the given condition. So 2 is a root of ax square plus bx plus c equals to 0. So therefore 2 has to satisfy the equation. So that implies apply. So in the place of x write 2. So what we have? A 4a plus 2b plus c equals to 0. So equation 1. So this is a given condition. Now we have to find the point of concurrency of this line. So what is the family of lines? So given lines implies what? Ax plus 2by plus 3c equals to 0. So here to find the point of concurrency, we need to bring this one to the standard form. What is the standard form? L1 plus lambda L2 equals to 0. L1 plus lambda L2 equal to 0. To bring this one to standard form, what I am doing? I am replacing the c value from here. So what is the c value? So that implies a c equals to minus of 4a plus 2b. C equals to minus of 4a plus 2b. Right here c value. So that implies ax. So 2by plus 3 into. So it is a minus of 4a. So plus 2b equals to 0. Now expand. So that implies ax plus 2by minus 12a minus 6b equals to 0. So from this one I can take in this two a common. So what we get? A into x minus 12, then b common. If you take b common, so 2y minus 6 equals to 0. So L1 plus lambda L2, otherwise so mu L or pi or anything. So here you can write the family of line in this manner. Otherwise so lambda 1 L1 plus lambda 2 L2 equal to 0. That is also same family of lines. If you divide by lambda 1, it becomes same. So if you divide by a, what we get? So that implies so if you divide by a, what we get? So x minus 12 plus b by a whole into b by a. Here what I am doing? Dividing by a. So 2y minus 6. So 2y minus 6 equals to 0. Now see, this one is in the form of. So it is in the form of L1 plus lambda L2 equals to 0. L1 plus lambda L2 equal to 0. So from this one, L1 equal to this one. L1 implies x minus 12 equal to 0. Therefore, So from this one, x value we get directly. So x minus 12 equals to 0. X minus 12 equals to 0. So x equals to 12. Second one, so 2y minus 6 equals to 0. So y equals to 3. Means therefore point of concurrency. So point of concurrency equals to 12 comma 3. First option. Means whenever this type of questions are given, so definitely you observe so some condition will be given. So using the condition, so bring the family of lines into the standard form, this form. L1 plus lambda L2 equals to 0. L1 plus lambda L2 equals to 0. Okay. Next one. See. Again same. So here ax plus by plus c equals to 0 and bx plus cy plus a equals to 0, cx plus ay plus b equal to 0 are concurrent. Then so we have to find the value of so a square plus b square plus c square upon ab plus bc plus ca. So in the previous case, so lines are concurrent. So from this one, what is the value determinant of ABC, then BCA, then CAB equals to 0. Just now we did. So what is the result? A cube plus B cube plus C cube minus so 3ABC equal to 0. So from this one we have the result that implies a plus b plus c into a square plus b square plus c square minus ab minus bc minus ca equal to 0. Okay na? So use this condition, a square plus b square plus c square. That implies a square plus b square plus c square minus ab minus bc minus ca equals to 0. So that implies a square plus b square plus c square equal to how much? AB. A square plus b square plus c square equal to AB plus BC plus CA. AB plus BC plus CA. So obviously this becomes 1. Okay na? I think this is a third question of this pattern. A cube plus B cube plus C cube equal to 3ABC. Then we have the condition a plus B plus C into a square plus B square plus C square minus AB minus BC minus CA equal to 0. Otherwise you can derive directly, not an issue. Okay na? See how to derive. If you want to derive, see determinant of ABC, BCA, then CAB equal to 0. I am applying the condition. So R1 changes to R1 plus R2 plus R3. So that we have a plus B plus C. So here B plus C plus A. Then here C plus A plus B. So remaining BCA CAB equals to 0. We can take a plus b plus c out common. A plus b plus c whole into determinant of 1 1 1. So BCA CAB. Here again what I am doing? So C2 minus C1, apply the condition. C2 changes to C2 minus C1, column 2 minus column 1. C3 changes to C3 minus C1. So that we have a 0 here. Okay na? So if you apply that one, that implies a plus b plus c into determinant of column 1 same 1 b c. So 0 c minus b, then c minus a, then 0 a minus b, b minus c equals to 0. If you simplify this one, we get this condition. a square plus b square plus c square equals to ab plus bc plus ca. Okay. Next one. See here 3 lines. If the lines p1x plus q1y equals to 1, second one p2x plus q2y equals to 1, and the third one p3x plus q3y equals to 1. So 3 lines are again concurrent. See, lines are concurrent. Given lines are concurrent. That implies a, so determinant of so here p1 q1 minus 1, then p2 q2 minus 1 again, so p3 q3 minus 1 equals to 0. Okay na? In the next step you take out minus common and multiply by half on both sides. I can write this one as a half of so p1 q1 1, p2 q2 1, p3 q3 1 equals to 0. It is nothing but what? Area of triangle formed by the points p1 q1, p2 q2, p3 q3. So that implies a, what is the result? So that this implies a area of a triangle ABC equal to 0. If you say this one as A, this one as B, this one as C, area of triangle ABC equal to 0. Area of triangle ABC equal to 0 means that implies points are collinear. A comma B comma C are collinear. Means given points are collinear. Means lie on the same line. First option. Okay. Next one. See here. Equation of the line. So passing through the point of intersection of the lines and perpendicular to this one and perpendicular to this one. Means here say given lines are first one say some L1, so 2x plus 3y minus 1 equals to 0. L2, so 3x plus 4y minus 6 equals to 0. And L3, so L3 implies what? So 5x minus 2y minus 7 is equal to 0. 3 lines are given. Now equation of the line passing through the point of intersection of L1 and L2. So this one is a L1 and L2. This is a required line. So it is passing through the point of intersection, right? So solving L1 and L2. So solving L1 and L2. So first write the y coefficient 3, then constant 1, constant minus 1, x coefficient 2, again repeat 3 here. Then y coefficient 4, constant minus 6, x coefficient 3, then repeat 4 here. Then x upon, so it is a minus 18, minus half minus plus 4. Okay na? Equals to, this will be minus 3, okay na? Minus 3, so minus half minus plus 12 equals to 1 upon, so this will be 8 minus 9. 8 minus 9. Therefore, so what we have x minus 14 equal to y by 9 equal to minus 1. Equate first one last one, x equal to 14, y equals to minus 9. Therefore point of intersection equal to how much? So 14 comma minus 9. Point of intersection 14 comma minus 9. Now, so what we have to find? So we have to find the line which is here. I got the point. Then to find the equation, slope is required. Slope is required. So it is perpendicular to this one. It is perpendicular to this one. Means this line is perpendicular to this one. So it is a 5x minus 2y minus 7 is equal to 0. Okay now, this is a required line. This is a required line. So to find the line we need point and slope. Here I find the point. So slope, this line is perpendicular to this one. So here what is the slope of this one? Slope is equal to minus a by b. So it is a 5 by 2. Slope of the required line, reciprocal and change the sign. So this will be minus 2 by 5 equal to m. If you know the slope and line, if you know the slope and point, we can find the equation. Therefore, equation of line is what? So therefore, point x1 y1 is equal to 14 comma minus 9. Then slope m is equal to how much? Minus 2 by 5. Is that okay? 14 minus 9 minus 2 by 5 minus 2 by 5. Then equation of line y minus y1 equals to, therefore required line y minus y1 equals to m into m value. Here m value minus 2 by 5 into x minus x1 14, cross multiply. So 5y plus 45 equal to minus 2x minus half minus plus 28. That implies bring to the left side. So 2x plus 5y 15 minus 8 17 means 2x plus 5y equal to 0. Option 2. Okay, simple one. Here first find the point of intersection, then find the slope, then point slope form y minus y1 is equal to m into x minus x1. Next one. Go through the question. If A and B are the intercepts made by the straight line on the coordinate axis such that 1 by A plus 1 by B equal to 1 by C, then the line passes through the point. Simple one. Okay. So first, what is the given condition? See, if A and B are intercepts, okay na? If A and B are intercepts, then equation of line will be what? X by A plus y by B equal to 1. Intercept form, this one we know, right? Now what is the given condition? Given 1 by A plus 1 by B equal to 1 by C. From this one, so we have a C upon A plus C upon B equals to 1. Now you observe what we are getting. In the place of X we are getting C, in the place of Y we are getting C. Therefore, so this line, so line passing through the point, line passes through the point. In the place of X, C, in the place of Y, C. So this line is passing through which point? So it is passing through the C comma C, means option 2, second option. Okay. Next one. See, this one is a beautiful question, very good question. Consider the points A01 and B20 and P be a point on the line 4x plus 3y plus 9 equal to 0. P is a point on the line 4x plus 3y plus 9 equal to 0. So coordinates of P such that PA minus PB is a maximum. Means here we have to find the P coordinates which lies on the given line according to the condition PA minus PB is a maximum. PA minus PB is a maximum. Okay. Now plot the points on the graph. See here, see, if you take the coordinate axis, x and y, somewhere A 0 1 lies on y axis 0 1, then B 2 0 lies on x axis, Now this line here 4x plus 3y plus 9 equal to 0. X interceptor minus b minus c by a minus c by b, negative, means a line may be somewhere, this is a given line, this is a line, okay na. So this is a 4x plus 3y plus 9 equal to 0. Now what is the question? P is a point on the line, assume if P is here somewhere, if this is a P, this point is P, okay na. So this is a AB, So what is a PA? This is a PA, this is a PB, okay. This one is a PA, this one is a PB. If you take the point here, okay now. So here it is evident that you can see we have a triangle ABC according to triangle inequality. So here triangle inequality. So what is the triangle inequality? Sum of any two sides always more than third one, means so here AP plus AB is a greater than PB, right, in this triangle. So AP plus AB is a more than PB. So from this one, so you can take PA other side, otherwise you do one thing, you take these two sides. Here you can take PB, you can take any two sides, PB, here PA, okay na. So from this one what we are having, so AB is more than, so PA minus PB means a PA minus PB is always less than AB. Got the point? So PA minus PB always less than AB, means we have how many possibilities? Infinite possibilities. You can take P here, anywhere. So always it is a less than AB. So when you get maximum possibility, so means if you take P here, means in this case, so what is the PA value from here, okay na. So PA minus PB, what we get? We get AB, okay na, you get a AB. So if you take means if PAB are collinear, then mod of so PA minus PB, so PA minus PB equals to how much? Equals to AB, means we get maximum possibility, when the points are collinear, okay na. So you must get an idea of this one, okay na. When we have the maximum possibility, so if points are collinear, then we have the PA minus PB will be maximum. So here how to find P coordinates? We have to find P coordinates, okay na. We have to find P coordinates. You look at the diagram. So P is the point of intersection of this line and this line, okay na. So here P is the point of intersection of these two lines, means it is the point of intersection of AB and this line. So solving these two, we get the P coordinates. So first find the equation of AB. equation of AB. So equation of AB, apply 2-point form, So y minus y1 equal to y2 minus y1 0 minus 1 upon x2 minus x1, 2 minus 0 into x minus x1. Now cross multiply, that implies that 2y minus 2 equal to minus x, that implies x plus 2y minus 2 equal to 0, equation of AB. Now what is the given line? So given line implies a 4x plus 3y plus 9 equal to 0. Solving these two, multiply by 4 here, change the symbols, 4x get cancelled. So here 8y minus 3y, 5y, so minus 8, so this is a minus 8, then minus 9, so minus 17, okay na, minus 8 minus 9, minus 17 equal to 0. So from this one y value equal to 17 by 5. If you replace the y value, you get x value. What will be the x value? So x plus 2y. So 2y means so 34 by 5 minus 2 equal to 0. X plus 24 by 5 equal to 0. X equals to minus 24 by 5 means this is a required point. Okay na? So whenever PA minus PB is a maximum, so points must be collinear. Make a note of this one. Then next one. Again same pattern, but here condition is a PR plus RQ. Sum is a minimum. Their difference was maximum. Now sum is a minimum. See here P 1, 1 and Q 3, 2 are the points on. Then we have to find the point on x-axis. Here R lies on x-axis. P 1, 1 and Q 3, 2 be given points. The point are on the x-axis such that PR plus RQ is minimum. So if the question is like this, see here first locate the points. X-axis, right? P 1, 1 somewhere here. P 1, 1. Then Q 3, 2 somewhere here. Q 3, 2. Okay? So this is a PQ. Now we have to find the point on x-axis. Say R somewhere here. R. We have to find the point such that PR plus RQ is minimum. So PR plus RQ is minimum. So if the questions are like this, okay na? So you see here these 2 points lie on the same side of x-axis. P and Q lies on the same side of x-axis. So to find the minimum value, you take the image of this one with respective x-axis. So image of Q somewhere here. Image of Q. Say some Q dash. So what is the coordinates? Coordinates are x same, y minus 2. See. Take R here so that we have a somewhere here R. So if they are minimum, then these 3 must be collinear. Okay na? So this one is the image of this one. So here if PR plus RQ is minimum, then so PR Q dash must be collinear. Now so here how to find the R value? We know the coordinates of P, we know the coordinates of Q dash. Find the equation of PQ dash. Therefore equation of PQ dash, again 2-point form. again 2-point form, y minus y1 equal to y2 minus y1 minus 2 minus 1 by x2 minus x1 3 minus 1 into x minus 1. Cross multiply, 2y minus 2 equals to 2y minus 2 equal to, this is a minus 3x minus half minus plus 3. Therefore, equation of PQ is what? So 3x plus 2y equals to 5. Now here r lies on x axis, so coordinate say some x comma 0, y coordinate must be 0, put y is equal to 0. So if y is equal to 0, then x coordinate is a 5 by 3. Therefore r coordinates will be, so 5 by 3 comma 0. Okay, two important methods. Previous one was what? Difference was a maximum. Now sum is a minimum. So this is a method. Otherwise you can do this one by using the maxima minima in the differentiation. Find the distance PQ, find the distance PR, then distance RQ, then after that, so differentiate, you can find the minimum value, but this one is a better one. Okay, next one. See, again condition is given, family of straight lines is a, then here, so what are the point of concurrency? Okay, now if 4a square plus 9b square minus c square plus 12ab equals to 0, then family of straight lines is concurrent at. Okay, so first you take the given condition. So given 4a square plus 9b square minus c square plus 12ab equals to 0. So here it is nothing but, so 4a square plus 12ab plus 9b square minus c square equal to 0. It is nothing but perfect square of it is a, so 2a plus 3b whole square. Am I right? A square plus b square plus 2ab equal to c square minus c square equal to 0. From this one, so 2a plus 3b whole square equal to c square. So from this one, so c value equal to plus minus 2a plus 3b. Now take the family of lines. Now family of lines implies ax plus by plus c equal to 0. ax plus by plus c equal to 0. If you take plus symbol, what we get? That implies a ax plus by in the place of c. I can write 2a plus 3b equal to 0. So from this one, x common, a common. So x plus 2, then b common, y plus 3 equal to 0. So divide by a, x plus 2 whole into b by a, y plus 3 equal to 0. It is in the form of L1 plus lambda L2 equal to 0. What is L1? X plus 2 equal to 0. From this one, x is equal to minus 2. Here y plus 3 equal to 0. Y is equal to minus 3. So one possibility is a minus 2 minus 3. Same, if you take minus sign here, what we get? So ax plus by minus 2a minus 3b equal to 0. So it is a common, x minus 2 plus b common, y minus 3 equal to 0. So here what we get? X is equal to 2 and y is equal to 3. 2 comma 3 means option 1, 2, 3 are minus 2 comma minus 3. Okay. Next one. See, if ABC are three consecutive odd integers, then the variable line ax plus by plus c equals to 0 always passes through. Always means again, so condition directly not given. So by looking at the statement, you can identify the condition. ABC are three consecutive odd integers. So odd integers means you can take 135, anyone 135. So they are in what? They will be in AP. Okay na? If you take 135, they are in AP. So 3 minus 1, 5 minus 3. You can take a 7, 9, 11. Different same 2. Means consecutive odd integers will be in AP. That is a given condition. Okay. See, ABC are consecutive odd integers. That implies a comma B comma C are in AP. Arithmetic progression. What is the condition? Twice of B equal to A plus C. So from this one, value of C equal to 2B minus A. That's it. Now you can. So here, this is a variable line. So variable line is what? So variable line implies a ax plus by plus c equals to 0. Ax plus by plus c equal to 0. Replace the c value. That implies a ax plus by plus 2b minus a equals to 0. So here I can take a common. If you take a common, x minus 1, then b common. So y plus 2 equal to 0. That implies a x minus 1 plus b by a into y plus 2 equal to 0. So L1 plus lambda L2 equal to 0. L1 x minus 1 equal to 0. First one, x equal to 1. Here y is equal to minus 2. So 1 comma minus 2. Fourth option is the required one. Okay, simple one. See here, if T1 not equals to T2 not equals to T3 and the lines T1x plus y equals to 2a T1 plus a T1 cube, then next second one T2x plus y plus 2a T2 plus a T cube. See, you observe the given lines. So given lines are, first one is what? So T1x plus y equal to 2a T1 plus a T1 cube. Then second one T2x plus y equal to 2a T2 plus a T2 cube. Then next T3x plus y equals to, so 2a T3 plus a T3 cube. So if you observe the lines, one thing is it's clear that, so these three lines, okay na, see here, so what is a variable line? So here T1, T2, T3, okay na. So T1, T2, T3 are the roots of the equation. If you take the equation, so Tx plus y equal to 2at plus at cube, 2at plus at cube. This is the equation. If T1 is a root, T1x plus y, then equal to okay. So t1x plus y equal to 2at1 plus at1 cube. So if t2 is the root, so t2x plus y equal to tat2 means here, so t1, t2, t3 are the roots of the equation, roots of this equation. So here t1, t2, t3 are the roots of the equation, this one, roots of the equation, cubic equation. So cubic equation that implies a t cube in t, roots of the equation a t cube plus 2at minus tx minus y equal to 0, minus y equal to 0. Now see, if ax cube plus bx square plus cx plus d equal to 0 is a cubic equation. So what is the sum of the roots? x1 plus x2 plus x3, x1 plus x2 plus x3 equal to minus b by a, minus b by a, sum of the roots. So here it is in terms of t, in terms of t, roots are what? t1, t2, t3 are the roots. So sum of the roots, that implies sum of the roots t1 plus t2 plus t3 equal to here x square coefficient by x cube coefficient, x square coefficient by x square coefficient. Here t square term is not there, t square term is not there, so therefore 0 by a, that equal to 0, t1 plus t2 plus t3 equal to 0. So remember the formula for the cubic equation, sum of the roots minus b upon a. So here b value will be 0 because there is no t square term, there is no t square term. So minus 0 by a, that equals to 0. So t1 plus t2 plus t3 value will be 0. Okay. Otherwise you can simplify, it will be lengthy. Okay na? That is equal to 0, determinant equal to 0, evaluate, you will get t1 plus t2 plus t3 equal to 0. You can do like that also. Okay. Next one. See, if a variable line drawn through the intersection of the lines x by 3 plus y by 4 equals to 1 and x by 4 plus y by 3 equals to 1 meets the axis at a and b, then the locus of the midpoint. Now one question on locus. Okay. Now what are the given lines? Given lines are x by 3 plus y by 4 equals to 1. Another one, x by 4 plus y by 3 equals to 1. We have to find the point of intersection, no? Variable line is passing through the point of intersection. So solving these two. So it is a 4x plus 3y equals to 12. This will be 3x plus 4y equals to 12. Okay. So here multiply by 3, here multiply by 4, multiply by 4. Okay, change the sign. Change the sign. So here x cancel out. X cancel out. So here minus 9 minus 16 minus 7. Then 36 minus 48, 7y equals to, so it is a minus 12, okay na, 36 minus 48. So from this one y value 12 by 7, apply. So 12 by 7, then x also you get same, 12 by 7. So x also same, 12 by 7. So point of intersection is what? So 12 by 7, 12 by 7. Now come to the question. A variable line passing through this point and intersecting the axis at A and B. A and B means See, line is intersecting at A and B, variable line. Let a variable line say some x upon A plus y upon B equals to 1, y upon B equals to 1. So this is A, this is B. So A coordinates will be A comma 0, B coordinates will be 0 comma B. So we have to find the locus of the midpoint. So midpoint is what? A upon 2, B upon 2. We have to find the locus of midpoint. Say locus is midpoint is equal to say some x1 y1. So from this one A equal to how much? 2x1, B equals to 2y1. Means that implies a variable line implies a x upon A value 2x1, y upon B value 2y1 equal to 1. Now take the LCM. So it is a xy1 plus x1y equal to 2x1y1. So it is passing through which point? So passing through, given it is passing through the point of intersection of these two lines. So passes through the point. So 12/7 comma 12/7 apply in the place of x 12/7 y1 plus 12/7 into x1 equal to 2x1 y1. So 2 cancel out, take 7 other side. So 6y1 plus 6x1 equal to 7x1 y1. Therefore here we are finding the locus for x1 y1. Replace x1 with x and y1 with y. Therefore locus implies 6 into x plus y equal to 7xy. 6x plus y equal to second option 7xy equal to 6 into x plus y locus. Okay. Next one. Here one side of a rectangle lies along the line 4x plus 7y plus 5 equals to 0 and two vertices are given -3 1 and 1 1. Then the remaining vertices, okay, simple one. Here if you take this is a rectangle, one side is given no, one side say some A, B, C, D. Here one side is given and two vertices are given. Okay. So say this line is a 4x plus 7y plus 5 equals to 0 and the two vertices you observe -3 comma 1, -3 means 4 into -3 -12, 1 7 into 1 5 means -12 plus 12 gets satisfied, means definitely. So -3 comma 1 somewhere either this point or this point, -3 comma 1. So next 1 comma 1 is not satisfying this one, 1 comma 1. Now we have to find the remaining vertices, means we have to find the b coordinates and d coordinates, okay na. Here b coordinates, you look at the diagram, b coordinates are nothing but foot of the perpendicular. It is a rectangle, this is a right angle. If you drop the perpendicular, so this point is called foot of the perpendicular. Say if b coordinates are say some h comma k, then you can find the b coordinates by So h minus x1 by a equal to k minus y1 by b equal to minus of ax1 4 plus by1 plus c upon a square plus b square. So 16 plus 49. Equate first one, last one. H minus 1 by 4 equal to k minus 1 by 7 equal to how much? 7 plus 5, 12, 16 upon 65. Equate first one, last one. So h minus 1 by 4 equals to, means h minus 1 is equal to minus 64 by 65. So h equal to minus 64 by 65 plus 1. Therefore h equal to 1 by 65. 1 by 65 here means maybe first option, maybe third option, right? 1 by 65, 1 by 65 x coordinate. Then next equate second one, k minus 1 equal to how much? 7 6 4 11 112 upon 65. Then k equals to minus 112 by 65 plus 1 means k equal to minus 112 plus 65 by 65. So 12 minus 5 7, 10 minus, so it is a 47 minus 47 by 65. Obviously first option. After finding this one, then you can find the d coordinates. They bisect each other. Midpoint of AC equal to midpoint of BD. Okay na? After finding these are the B coordinates. Then midpoint of AC equal to midpoint of BD. So you can find the D coordinates. They will be minus 131 upon 65, comma 177 upon 65. Next one. See, again lines are concurrent. See here, but lines are different. See, given lines. So given lines are concurrent. So we have the condition determinant of from the first line 1 a, second line b1 b, third line c1 equals to 0, okay. Here a minus 1 and b minus 1 is required. So what I am doing c2 changes to c2 minus c1, c3 changes to c3 minus c1, okay. So c2 minus c1, c3 minus c1, that implies write the c1 same, 1 b c same, it becomes a minus 1 because I am performing c2 minus c1. Then this will be 1 minus b, this will be 0. Next this will be a minus 1 again, this will be 0, this will be 1 minus c equal to 0. Now expand, okay na? Expand along the first row. If you expand along the first row, so first 1 into multiply these two. So 1 minus b into 1 minus c, then minus 0. Then second one minus of a minus 1 into here b into this one. So b into 1 minus c, then plus a minus 1, leave the first row and third column, this will be 0, minus c into minus, here plus into minus, so minus c into 1 minus b equals to 0. So look at the question, a minus 1, b minus 1, c minus 1 are required. That's why what I am doing, minus common. So here minus half minus plus b minus 1, c minus 1. So here if you take a minus 1 is there, minus common, minus half minus plus b into a minus 1, c minus 1. Then third one, so here minus is there, minus common. So, plus c into a minus 1 b minus 1 equals to 0. This is a given condition. Sorry, this is a condition we got. Now, look at the condition. This is a required one. So, to get this one, what I am doing? Dividing throughout the equation by a minus 1, b minus 1, c minus 1. First write this one. B minus 1, C minus 1, then B, then C. See, here we have a, what we have a B minus 1 into C minus 1, B minus 1, C minus 1, plus B into A minus 1, C minus 1, plus C into A minus 1, B minus 1 equal to 0. That's it, no? Let's check once again. B minus 1, C minus 1, B, A minus 1, C minus 1, C, A minus 1, B minus 1. Now dividing by, so dividing by A minus 1, B minus 1, C minus 1, we get, so here B minus 1, C minus 1 get cancelled, we get 1 by A minus 1. So here A minus 1, C minus 1 we get cancelled. B by B minus 1. So here C by C minus 1 equal to 0. Here A by A minus 1 is required. Adding 1 on both sides. 1 by A minus 1 plus B by B minus 1 plus C by C minus 1 equal to 0 plus 1. If you take LCM, this will be A minus 1 plus 1. So 1 get cancelled. A by A minus 1 plus B by B minus 1, C by C minus 1 equal to 1. So required value equals to 1. Next one.